Literal equations can be a little bit tricky. It's where you have two or more variables in your equation, but all the other algebraic rules are the same. So don't let these other variables confuse you. For example, in this case here, we've got two x's, we've got m's and n's, but we're being asked to solve for x. So as we would normally do, we must bring the x's to the same side first. So let's do that. So that'll become x on m minus x on n. And let's bring the n to the other side, so that'll leave us with m minus n. Okay, the second thing we want to do now is get a common denominator, because we've got two fractions there and we can't add them until they have a common denominator. So let's make the common denominator m times n. That'll mean we'll end up with xn mn minus xm nm, that's a mouthful, equals m minus n. Our next step will be to combine the x's together. So let's make this now xn minus xm over mn. Now that we've got the same denominator, this equals m minus n still. Okay, now we're ready to solve. So the first step will be to times the mn to the other side. So make it xn minus xm equals m minus n in brackets lots of mn. Okay, now I didn't do it up here before, but I should have taken out x as a common factor so I can solve just x. So x comes out and this becomes n minus m equals m minus n and mn. Final step will be to divide through by that n minus m. Like this. This is your final answer, although this won't be the answer that the back of the book Bob has. Okay, sometimes you need to do a little bit of tweaking to get the correct answer. Look over here, this is m minus n, and over here it's n minus m, and they're very close together. So you might be guessing, or you should be thinking, that they might be able to cancel out in some way. One way to do this is to take a negative out of that bracket and make it n minus m, mn. Okay, so we're just taking, like, timesing it by -1, effectively. Minus m. That'll allow us to cancel that bracket, and we end up with minus mn, which is so much simpler than the previous answer. So this will probably be the answer you'll be looking to get to. The second example has simultaneous equations in it. So we've got three variables, a, s and h, and we're being asked to write s in terms of a only. So we want s equals, and on the other side we only want a's, no h's. So we're looking to eliminate the h, we're going to get rid of the h, because otherwise we're not going to be able to solve for s. In this case, because it's h equals, it's actually a nice straightforward one. We can do a substitution, and we can sub that a minus s straight into equation 1, which will leave us with as equals a plus 2 lots of a minus s. And now we don't have a h in our equation anymore. It's gone. Now, because we're solving for s, we want to get the s's to the same side. So first let's expand. Minus 2s. Bring the s's together. So as plus 2s equals a plus 2a. S's are a common factor, so we have to bring them out, otherwise we can't solve. And a plus 2a. And finally divide through by a plus 2. So s equals a plus 2a over a plus 2. And of course I should add a plus 2a. 3a over a plus 2.